Hello, welcome to this walkthrough session. And what we are going to do as part of this particular one is dive into an embedded OS by the name Little Kernel. Now, what we have done is we have forked a repository from the original Little Kernel repository, and it's an embedded kernel, so it's like a scheduler that runs on microcontroller and 64-bit RISC-V and ARM CPUs. What we are going to do is use this repository as a way to demonstrate as to how can you go about understanding a source code that's written in C and has too many files, too many projects, just too many things to work with, right? And as you can see, there are like too many directories here, and we have a fork available here that we are going to work with. And essentially, as part of that fork, we just added few commands here and there to help you kind of set up and get up and running. So maybe let me transfer it over to Mohammed here, and let's talk about okay, what is little kernel really? What is it?
Yeah. Okay. So as the name suggests, it's like a kernel. So it has all the niceties and goodness of scheduling, memory management, supporting of boot flow of multiple architectures, multiple boards, all of that. But with the added advantage of it being very lean. Uh,
Okay.
okay. And I forgot to mention, it has support for multiple file systems and multiple input output devices as well. Key drivers, all of it is there. So it is not as full fledged as Linux in terms of capability. Like Linux
Mm-hmm.
supports virtualization and then network boot stack and all of that. LK doesn't at this point at least. But what it does is it kind of mimics Linux in certain concepts and design. Like, hey,
Mm-hmm.
Linux
Mm-hmm.
provides you certain hooks, for example, which we'll obviously go and see in detail in this series. But just to whet the appetite, Linux provides you certain hooks that, hey, if your driver is entering into suspend or resume, here is a hook you can attach, and maybe I'll call that when
I see.
I as a kernel is going to suspend or resume. So such niceties, such design concepts are borrowed from Linux and introduced in LK. And the key goal here is that it's full-fledged enough to be a scheduler and a nice sort of a round robin environment, but with
Mm-hmm.
very lean and mean sort of code base. And
Okay.
even then you saw, like, it is still too large, but then
Right.
very very mean as compared to Linux.
So this is like a mid-sized repo, so to
Right,
speak,
right,
compared to Linux.
right, right.
And what I understand is, which we were talking about earlier also offline, which was
Hmm.
that in some sense, it it also is a good platform to understand the operating system
Oh,
primitives,
definitely, definitely.
right? And it essentially has those basic operating system primitives in it, mutexes, semaphores,
Yeah.
things like that. But also, it's a very cut down version of something that is
Right,
Linux like.
right, right. So it's
And
it's
so,
so
mhm,
it's comprehensible from the get go in terms of the code base at first might seem large, but then when you get a hang of it, it's much smaller
hmm,
compared to Linux. So it's
right,
comprehensible in that sense. Plus,
right.
the other nicety is that it's not just ported on one architecture. It has like RISC-V, ARM-M, x86,
Multiple CPU
ARM-X. Yeah.
architectures.
So if you are, let's say, whatever fundas we learn here, you can easily sort of map it onto another architecture if you are
Hmm,
sort of finding yourself working in that. So we are going
right,
to focus more on ARM A class, ARM
right.
64, but then it's very transferable to other architectures as well.
Right.
So,
And obviously, whatever we study here is essentially a reinforcement to whatever the other courses
precisely,
cover.
precisely.
Linker
So,
script,
right,
build utilities,
hmm,
ARM-M, ARM-A,
right.
RISC-V, C language, C pointers, everything.
I
That
think it's amalgam. It's going to be amalgamation or application of all of these.
right.
Right. And what we will do is we'll not deep dive into any concepts just because we already have a material, corresponding material for that, and we will link that
Correct.
as in when we cross that. But overall, our goal here would be to sort of make a sense out of how everything gets combines together piece by piece, and how it forms a sort
A
of
cohesive whole.
yes, yes, precisely. An environment which actually is proven to work out there, and
Hmm.
go into the usage of LK, where LK is used, and in fact, it's like billions of devices, in fact,
Right.
because
And
good,
one of the things then what we intend to do as part of this series is just kind of learn the tricks of dealing with an unknown code
yeah,
base.
yeah,
What
precisely,
questions do you ask? How do you find the answer? There is like, same hash defined in a million different places. How do you narrow down which one is the one that you want? How do you test things? How do you go about kind of confirming your understanding of the strange code base without documentation,
yeah,
right? So cool. So I think this is a pretty good background, a decent one, which is little kernel is just a scheduler. And what we're going to do is explore its source code and figure out the pattern and abstractions
right.
that they implement. Okay, with that being the
So,
background there,
can I
go
add
ahead.
just one last thing? The
Yeah.
reason why we choose precisely LK, I mean, we had a lot many options, 3 hours, XL6. We might cover that in some other series. But
Yes.
at this point, why we chose LK was because it's lean and mean. Obviously, we have covered that. But its applications, or rather usages, are tremendous. And one of the main
Hmm.
one is Android bootloaders. So you might have heard of the term ABL, which is Android bootloader. It's like literally based out of LK. It's like one of the very, very, I would say, important application of LK, being used and proven to work on
Hmm.
like billions of devices.
Right.
Yeah. Having
So
said that,
so essentially, all major semiconductor for like this phone makers use uh, Android bootloaders and modify it to kind of enable the driver for their chipset.
right,
So this is also kind of like very practically useful and
right,
a very active code base in terms of making contributions.
yes,
So that's another thing, which is if you like what's on screen here, what we are doing, you can actually go check out the original little kernel, source code and maybe make contributions to it. Right? So that's like a side effect of what we have here. And the original one is right here, github.com/littlecernel/lk. That's where you'll find the original one. We created a fork so that we can mess around with it, and that repo is available at github.com/pajamabra/lk-code-walkthrough. Okay, once we are here, I think I'll take over and explain as to how to set up this environment. So we wanted you to be able to follow along in a browser. So you don't need like a special machine. All you have to do is go to this code button. Well, before that, be sure that you're signed in into the GitHub profile, and then go right here and either click this plus button which says create a code space on master, or just click here which is create a code space on master. Once you do that, you will see a new window open up, and then within that, something like VS Code shows up. Now, in our fork, what we did was added few configuration files here. Well, maybe not here. Did you
I
remove it?
just
I
so
see.
we
Okay, okay.
follow it from the scratch.
Right. So in our case, then only thing we did was add some instructions, and we are good to go. So once the code space is ready, you will see something like so. At the bottom here, we have the terminal, and then at the top here, we have the README that is open. And let me go ahead and full screen, just so that we have the entire real estate to ourselves. And then what I'll do is I'll copy all of these and just paste it in the terminal here, and then like allow pasting, and then do not show again, paste. Okay, so what just happened here was I entered all of the commands listed here, and this is an attempt to kind of install the prerequisites for being able to compile the LK source code. So let me go ahead and do that again. Some of them actually did not install. Uh, do you want to continue? It says no. Let me just install it one at a time. I think let's just do that. Or what I can do is let me create a new thingy here and let me just install all of these at once. Uh, okay, so I do sudo apt update. Let's just kind of go step by step here and then do sudo apt upgrade. Right. So here I say yes. It'll go ahead and upgrade the
I see what was
the
happening. I think it was taking the next
new
line as
line.
an
Yeah.
input,
Yeah.
and it was like whatever is, if it is not Y, then it's no, and then I
No,
swap.
and yes, it was exiting and not installing all the utilities. But when I do it step by step,
Hmm.
it will go through. Okay. So then, and just a moment, actually, I need to bring this right here. Oh, actually, yeah, I need to bring it right here so our viewers can see. All right, perfect. So what we're doing here is we're essentially updating and upgrading the cloud Linux machine that the code spaces is. So when we clicked here and created a code space, which is called Silver Adventure in our case. So that code space essentially. Oh wow, okay. What do
Yeah,
I
just
do?
press
Okay,
OK. Yeah.
yeah,
I think it's
okay.
also
So
upgrading its kernel alongside.
ouch. Okay, yeah, okay, done. So what we have here is essentially VS Code within a Linux cloud machine, and we are then installing certain utilities and cross
Hmm.
compilers just so that we can compile and run little kernel. And what I'm going to show right now to you is essentially running an example on little kernel just so that your environment you can confirm
Hmm.
whether or not things work. And
Kind of.
once that's done, we'll move on to exploring what
Right.
little kernel
And
is.
while this is happening, I also want to call out one thing. If it's possible to go back to the repo, uh,
Oh, repo. Okay.
yeah, yeah. So here, if you see, guys, you might see, we are ahead of the main fork by some number of commits. And here, just to point out, we have done nothing much. It's just some small tweaks to make sure that the LK which we are compiling works fine with the code spaces environment.
Yeah.
So yeah, apart from that, we have not touched the LK code base at all. It's just a simple fork, and that's it.
Right. And in fact, if you have a local
Yeah,
Linux machine, then you can pretty much do all of
all
this
this.
on that. It's just that we wouldn't be supporting that environment because of slight changes. It becomes like a nightmare to support many learners. So we would rely on the code spaces because we can control that environment. Okay, then. So everything's installed, and I'm going to just execute this one line, which is scripts do QEMU. Obviously, not not Linux kernel, but the little kernel here is going to compile and be run within QEMU, and QEMU is quick emulator. It can mimic a hardware board and run the compiled binary. That's essentially the idea. For example, Raspberry Pi, it can emulate that. All right, so I'll go ahead, copy paste and run. LK is getting compiled. As you can see, there are just too many files that are getting compiled. And yeah, I think we'll just wait
Yeah.
for it to compile. So too many libraries, file
Mhm.
systems and whatnot. And right, so the compilation is almost done. Okay,
And here we are.
yes. So let's just talk about the fact that compilation is complete here.
Hmm.
The elf.bin, that is where the compilation is complete. And what it is doing is it is launching
Hmm.
QEMU with a Cortex A53 CPU with a memory of 512 megabytes and just
It's one core.
having one core, right? And the machine that it's using is called Word. Again, the details don't as much matter, but then the ELF file is being picked up from this path. No graphics, none of that. And what we see here is essentially
Hmm.
LK booting up,
Right.
right? And not only LK, well, here it's also, I don't know why it has like four CPUs. When I think SMP1 here
Ah,
means,
what happened here is The QEMU command got the instruction that hey, only emulate one core. But because LK was built with SMP mode, it default assumes that there are four cores if no parameter is provided. So
I have a slightly different understanding.
okay,
I'm thinking the SMP here means whether or not SMP is
is support.
enabled on QE. Yes,
Hmm.
not the number, of course. We
I
can
see.
confirm that. We'll find it out using the
Right.
QEMU
Can you just
command.
scroll down, page? I have one other way to check. Creating bootstrap completion. Okay. Uh, let's find out. I think also prints some message from the course like hey, booting from core one, hello from core two, core
By
three.
the way, it says here found one
Yeah.
CPU.
So I think SNB might mean that it's only one, but we
Yeah,
get back to our readers. Lot.
exactly. And also, by the way, this is part of the journey. Like once we have jumped into a source code, the usual thing to do is just try out the default step that comes with like the bare minimum readme or bare minimum documentation, if at all.
Yeah.
And the idea is to get that code running somehow as
Hmm.
a starting point, because
Yeah.
once you know it runs, for example, we now have some starting point. We can start to, for example,
Yeah.
select this and then quickly try and see where that is coming
Okay.
from. So instantly we know that there is some
Hmm.
main.c, right? And this is essentially how the exploration proceeds. And
Yeah.
slowly we're going to draw maps and graphs and figure out as to what's going on,
Hmm.
right? Perfect. So what we have here then is the LK prompt.
Yeah.
And these are like the LK commands that are available to us. And that's about it. We managed to get LK to compile and boot.
Right.
And that's
Maybe
like
Piyush, just as a proof of our code is getting compiled, do you want to change that print statement and
Oh, sure. So, yes, let's do that. So, how do we execute the QEMU environment? It's Control A followed by
hmm.
X, and the QEMU terminates. So, as Mohammed was suggesting, I just, you know, uh, Command Shift F on my Mac, and I came to this search panel essentially
Hmm.
and search for welcome to LK/MP. Then we go to this main.c and let's just say from pajama bras,
Hmm.
right? How about that? And then what I'll do here, okay, don't show me. I'll do make clean.
Or rather, we can execute the same script, it will do everything.
Oh, okay, this do clean or
Yeah. No, no, it's fine. I think it will compile it again and then launch.
okay, okay. So let me then do this and then okay. So it's compiling again. Fine. So somewhere here we should see welcome.
Yeah.
Right. So welcome to LK from Pajama Brass, right?
Hmm.
Something like that. So
Okay.
which then means our code is at least
Right.
getting
I
compiled.
think this is a very important step, right? It might not sound or look much, but it's sometimes when code base is so long and so huge, you don't even know whether the file you're changing is getting
It's
compiled or
compiled or
not. And
not. Yeah.
it's
Yeah.
hidden under some compile time macro. It's
Right.
it's in some library which is not getting loaded. So many
Right.
situations can be there. So
Right.
first thing which we would recommend to try is a get some look for any print, search in the code base, try to tweak it, reload,
Recompile and rerun.
recompile, and yeah, retest it and see if your print comes. And that way you have made sure from the horse's mouth straight that it is indeed your code which gets compiled and takes effect.
Right. And so the clue for us right now is we at least have one file
Yes, yes.
that we know we can mess with.
Right, right.
And the idea is now that the print that we have here, we work backwards,
Right.
forwards, and find out all sort of things.
Yeah.
Okay, again, if I go to this Explorer view, this is all of the LK code,
Hmm.
many different
Right.
directories, many different make files here. There are scripts,
Hmm.
there are targets, and it's all very disorienting. And what we are going to do now is peel the onion one at a time
Yeah.
and work backwards. And
Right.
we are going to. There's no structured path to this, so we'll just take the
Yeah.
natural, curious path.
Right. And deliberately we have kept it like there is no preparation which
Yes,
we have done earlier. It's like hey,
yes,
let, let it go with the flow, so
yes.
it comes out naturally. Whatever we would deal in the day-to-day
Right. And in fact, you can do this on the side on your own as well. We encourage you to do that. Okay, perfect.
Then
That
one
said,
last thing,
go ahead.
the the build folder on the right, I think the fourth entry, yeah, this is
Ah,
where the compiled binaries of LK are. So if you want to take a look at the map files,
right.
the symbol files, all of that, you are welcome to do so.
Yes, and that's one thing that I go look
Hmm.
for. So, for example, when the compilation is done, and let's say we only compiled and did not launch
Hmm.
QEMU, the one thing I do is find iname star.elf, and usually
Correct.
that reveals where the binary is.
Yeah.
Right? And typically things like build, out,
Hmm.
output, release, debug, these are
Right.
like nice keywords in the path that suggest that maybe this is the
Yes.
binary.
Yeah.
Right.
And maybe Piyush, because we are here, maybe you wanna open up the lk.elf.sim file.
Yes.
So this is where you would find where your symbols are placed and what is the address. And if it doesn't make too much sense to you, we would encourage you to go check out the
Yeah.
linter course. So that will
Yes.
make a complete sense of where each symbol is placed and how do you dictate that. So that is a
Yes.
cool.
So, by the way, and again, these are like familiar names to us, again, because of the other courses and, command line utilities, build tools, um, all of this is explained there. And because of such extensions or such file names, we get a hint as to, okay, there might be something interesting here,
Right, right.
right?
For
And
example, another example, the lk.elf.debug.lst, the name suggests that it should have the disassembly of,
and debug information, yeah, yeah, yeah,
so it has like disassembly of all entire code.
right. And again, how to generate this? Yeah, part of the build tools and command lines utilities course. And okay, cool. So I think we have a starting point. We blabbered and went in different directions here, but this is where we start. And so what we'll do is stop here right now. You can try out all of what we did, and then in the next one we'll start our random forensics and
Right.
exploration. All right. So with this, we'll see you in the next one.